This is the initial dataset, representing the number of hours users spend on a website daily. We'll be using this data to test the scikit-learn binarizer. The data is presented as a one-dimensional array. However, the scikit-learn binarizer requires a two-dimensional array as input. To prepare the data for the binarizer, we need to reshape the 1D array into a 2D array. This is done using NumPy's reshape function. Reshaping doesn't change the data values, only their arrangement. This shows the reshaped data. Each original data point is now in its own row within a column. This is the format needed for the binarizer. This line introduces the scikit-learn binarizer object with a threshold of 5. The binarizer will convert values into 0 or 1 based on this threshold. This is the output of the binarizer. Values less than 5 are mapped to 0, and values greater than or equal to 5 are mapped to 1. The binarizer returns a NumPy array, which is a common data structure used in scikit-learn for efficient numerical computations. This introduces the multiple choice question. We are asked to identify the true statements about the binarizer's output based on the analysis we just did. This is one of the options in the multiple choice question. It's incorrect, because it represents a flattened array, not the 2D array structure returned by the binarizer. The output of the scikit-learn binarizer, a tool used for preprocessing data, is always a NumPy array. NumPy, numerical Python, is a powerful library in Python that provides efficient ways to work with numerical data. This is important because many machine learning algorithms in scikit-learn expect input in this format. The output of the scikit-learn binarizer, a tool used for preprocessing data, is always a NumPy array. NumPy, numerical Python, is a powerful library in Python that provides efficient ways to work with numerical data. This is important because many machine learning algorithms in scikit-learn expect input in this format. This line simply introduces the multiple choice question about the scikit-learn binarizer's behavior and output based on a given dataset. This sets up the task for understanding the binarizer's functionality. It is asking whether you understand how it processes data and what its output characteristics are. This line simply introduces the multiple choice question about the scikit-learn binarizer's behavior and output based on a given dataset. This sets up the task for understanding the binarizer's functionality. It is asking whether you understand how it processes data and what its output characteristics are. This is the actual question being asked. It's prompting a critical analysis of the result of the binarization process on a specific dataset to check your understanding of the binarizer function in scikit-learn. The question sets up a scenario with a specific threshold and data, leading to possible answers to be evaluated. Remember, the threshold of 5 means any number greater than or equal to 5 gets converted to 1, and anything less gets a 0. This is the actual question being asked. It's prompting a critical analysis of the result of the binarization process on a specific dataset to check your understanding of the binarizer function in scikit-learn. The question sets up a scenario with a specific threshold and data, leading to possible answers to be evaluated. Remember, the threshold of 5 means any number greater than or equal to 5 gets converted to 1, and anything less gets a 0. This is the initial data, representing the number of hours users spend on a website daily. It's the raw material we'll use for our binarization process. This is the critical value that separates the data into two groups: those above or equal to 5, and those below 5. Think of it as the cutoff point for our high and low user engagement categories. This is where the magic happens. We're transforming our numerical data into a binary form, zeros and ones, using the threshold we've set. Each data point will be converted to either a 0, if below the threshold, or a 1, if at or above the threshold. This is the result of the transformation. Each element in the original data is now represented as either 0 or 1, based on whether it's below or above the threshold. Notice that the format is a NumPy array, which is common in scikit-learn. Scikit-learn, the library we're using, works efficiently with NumPy arrays. The output being a NumPy array is expected and reflects this compatibility. This ensures fast and seamless data manipulation within the scikit-learn ecosystem. This line introduces the topic, a step-by-step guide on using scikit-learn's binarizer. Scikit-learn is a popular Python library for machine learning, and the binarizer is a tool used for data preprocessing, specifically, to convert numerical data into binary, 0 or 1, data. We'll learn how it works and apply it to a simple dataset. Get ready. This line indicates that a dataset will be used as input for the binarizer. Datasets are collections of data points, each with multiple attributes or features, which are essential elements for training machine learning models. This is our starting point. This is the actual numerical input data. It represents the number of hours users spend on a website daily. Each number is a data point. We'll use scikit-learn's binarizer to transform this data into a binary representation. This is the data we will be working with. Let's see what happens. This line shows that we are using the scikit-learn binarizer function, setting the threshold parameter to 5. The threshold determines the cutoff point. Numbers equal to or above 5 will be changed to 1, and those below will become 0. Think of it like a gate. Anything above or at 5 passes through, becomes 1. And anything below gets stopped, becomes 0. This line serves as a heading to indicate that the following line will show the result of applying the binarizer. The output will be the transformed data, our original numerical data converted to binary form. Let's see the results. This is the output of the binarizer. Each inner list represents a single data point from the input. The value is 0 or 1 according to whether the original value is below or above the threshold of 5. Notice how the output is structured. The binarizer produced a new array rather than changing the original in place. This line specifies that the output of the binarizer is a NumPy array. NumPy is a powerful Python library for numerical computation. NumPy arrays are efficient and well suited for mathematical operations. NumPy arrays are a common data structure used in scikit-learn, facilitating efficient calculations and operations. This line introduces the data representing the number of hours users spend on a website daily. The data, 1, 5, 10, 2, 8, 3, is crucial for applying the scikit-learn binarizer and understanding the transformation process. This is the raw data we'll be working with. Let's move on to see how we'll use it. This specifies that we are using the scikit-learn binarizer function with a threshold value of 5. The binarizer is a tool that converts numerical data into binary data, 0 or 1, based on this specified threshold. Numbers at or above 5 will become 1, and numbers below 5 will become 0. This is the core of the transformation process. This line describes the key step, taking the input data and applying the binarizer to it. The binarizer will analyze each value in the input data and convert it to a binary value, 0 or 1, according to the threshold set at step 5. It is the application of the function which uses the threshold value to convert input data to an output. This is one of the multiple choice options. It suggests a possible output of the binarizer transformation. However, it's important to note that this representation is slightly simplified. The actual output will be a 2D NumPy array, as shown in the next line. This is because scikit-learn expects the input as a 2D array. This option correctly states that the output of the binarizer is a NumPy array. NumPy is a powerful Python library for numerical computation, and scikit-learn relies heavily on it for efficient data manipulation. The result of the binarizer will be a structured array compatible with other scikit-learn functions.